All right, so let's try to summarize what we've learned about factories. So first of all, we looked at something called factory method, which is a method, typically a static method, that is capable of creating objects. Then we talked about the general idea of a factory as just any entity that can take care of object creation. Typically, when we talk about a factory, we talk about a class, but that's not necessarily the case. For example, if you have a method and that method takes a lambda that creates objects, then you have a factory wrapped as a little anonymous function. We also talked that a factory is a. separate class can either be external, so it can reside as a completely separate entity, or you can actually put it as a nested class inside the class which it actually creates. And finally, we looked at hierarchies of factories that can be made to correspond to hierarchies of types and can be used to easily create related objects. In this section of the course, we're going to talk about the prototype design pattern. So what is the motivation for using the prototype design pattern? Well, if you think about the real world, complicated objects such as cars or iPhones or anything like that, they are typically never design from scratch. You don't design a car just by starting with a blank sheet of paper and drawing a car. That's really not how it works. Instead, what you do is you reiterate existing designs. You look at what people have already done and you try to improve upon the existing constructs. And the prototype design pattern goes in the same vein because essentially the idea is that you've already got some sort of existing design and you want to simply make a copy of that design, customize it somehow, and then start using it. And that design, it can be a fully constructed design that you simply want to change, or it can be partially constructed with some. In this section of the course, we're going to talk about the prototype design pattern. So what is the motivation for using the prototype design pattern? Well, if you think about the real world, complicated objects such as cars or iPhones or anything like that, they are typically never designed from scratch. You don't design a car just by starting with a blank sheet of paper and drawing a car. That's really not how it works. Instead, what you do is you reiterate existing designs. You look at what people have already done and you try to improve upon the existing constructs. And the prototype design pattern goes in the same vein because essentially the idea is that you've already got some sort of existing design and you want to simply make a copy of that design, customize it somehow, and then start using it. And that design, it can be a fully constructed design that you simply want to change, or it can be partially constructed with some pieces missing, and then you can add those pieces and manufacture the completed object. So what do we typically do when we want to use a prototype? Well, we make a copy. We take some object and then we copy or clone the prototype, and then we customize the resulting instance and give it to the client to consume. So of course, in order for this to work, you need something called deep copy, and that is essentially a wholesale copy of the object. We're going to take a look at how this is implemented in Python. And we also want to make cloning convenient. So what we can do is we can, for example, build a prototype factory where you have a few predefined designs and then you ask the factory to customize this design, giving you essentially a custom item. All right, so a prototype is a partially or fully initialized object that you copy or clone and then you subsequently make use of it. So the essence of the prototype design pattern is all about our ability to copy objects. So let's take a look at a scenario where this would become relevant. So for example, let's suppose I make a class called person. So we're going to describe a person in terms of their name as well as their address. So in the constructor, I'll take the name and the address, and I'll just set them, this name equals name, this dot address equals address, like so. And then let's define address as well, because address is going to be a composite object as well. So address is going to be a class. We'll have a constructor where you specify the actual street address, the city, as well as the country. And you can think of other things to add here, like postcode, for example. So street address equals street address, city equals city, country equals country. There we go. So now that we have this definition of person, what we can do is we can create one person. So let's make John. So John is going to be a new person with the name John, and their address is going to be a new address where we specify the street address, can be 123 London Road. Let's suppose they live in London and in the United Kingdom. So that's John. Now, John can serve as a prototype for additional people that happen to live in the same building as John, meaning that instead of instantiating their address once again, we might want to copy it, or we might want to customize it a little bit in the case that it's not exactly the same building, but it might be their neighbor or something. So how do you copy objects in JavaScript? That is the key question of the whole prototype design pattern. So the way you can try copying it is by writing something like the following: let Jane equals John. Now, this is obviously wrong, but let's just flesh out why it is wrong. So I'm going to have this new object, Jane, and I'm going to customize it. So let's suppose that Jane also happens to live in London in the UK, but her name is different and her street address is different. So we can say Jane.name equals Jane, and we can say Jane.address .street address equals 321 Angel Street. I didn't even know if there is such a street in London. Maybe there is. So now that we've got this, let's try actually printing both John and Jane and seeing what we get. So I'm going to log John, and I'm going to similarly log Jane. Now, I do wonder if I'm going to get any nice output here because I haven't implemented a string. As you can see, we just get a bunch of objects, which isn't particularly exciting. So let's go back into the code and actually implement something that shows the object in a nicer way. So for the address, let's implement toString. Here, I'm going to return the actual address. So the actual address is going to be street address. And let's also have, obviously, the city. So city and country. There we go. So this is the address. And we also want toString for the person themselves. So let's do that. So here I will define toString as follows. So what I'm going to address, and so yeah. Let's do it like this. So we're going to have this name. So that should hopefully work. And we can try this again now. Okay, so as you can see, we already have a problem because we're printing both John and Jane, but we're getting exactly the same results, which shouldn't really surprise you because if you look at the code, if you look at this line that we wrote, what we really did is we just overwrote the reference. So we now have both Jane and John actually refer to the same object, the same memory effectively. So when we write Jane and 321 Angel Street, we write it to the same memory for both John and Jane because they refer to the same object. So the question is, well, we don't really want them to refer to the same memory. How can we actually get them to refer to different memory? So there are different ways of approaching this, but the one we're going to go for is where we're going to basically support copying explicitly. So we're going to support this idea of just copying the object wholesale. So let's suppose that we go into person and we define some sort of deep copy method. Okay, so the idea is that whenever you want to copy a person, you make a new person with the same attributes. So you return a new person which has this .name and this .address. So it's as if you're actually copying the whole thing. But this will not work either. Let's now go down here. So what if I do the deep copy now? So I am supposedly trying to make a replica of the object that we can customize. But if I run this now, you'll see that we still have a problem. So their names are now different, which is good because obviously we copied the name over, but their addresses happen to be the same. Why is this happening? What is the problem here? Well, the problem is that when we pass the address in here, unlike with a string where it gets copied wholesale and you can customize it, the address is still a reference. So both objects, both the original object as well as a deep copied object, they still refer to the same address. So what we need to do, as you may have guessed, is we need to deep copy the address as well. And of course, in order to implement this, you have to have deep copy inside address. So inside address, you would return a new address where you a country. So if I run this, you see that now the objects are completely different. So what did we do here? Well, we made a prototype. So John is effectively a prototype that you make copies of. You customize those copies and then you reuse them for whatever kind of tasks you need. There is a limitation to this approach. There is a fairly obvious limitation. If you have objects, we choose other objects, we choose other objects in a very complicated kind of tree-like relationship, then you have to implement deep copy for every single composite object inside your entire object model. So if you want an object to be deep copyable, you also need all of its non-primitive members to be deep copyable as well. And this is a bit of a headache in terms of how much work you have to do to actually support those operations.